Hi everyone, it's Damien for another video. Um, as you can see, the code has been improved a little bit since the last video. On the last video though, the first version of the convert method was this one, which I didn't really like, and I think you can see the difference here because I changed it. So basically, you you're going through a first in a loop. You're checking if the number is indivisible by the factors in the table, and if it is, you initialize. If it's not divisible, so you initialize the sound with the number to string, and if it's not, you initialize a sound with an empty string. And well, this is basically a loop here, and after that you're going through another loop right here to sort of build the sound. But you already know, in the case that the number is indivisible, you're going anyway through that loop, which I didn't really like. And after that you return the result. And what I did was I did that. So I return the number is a I return directly the number as a string if the number wasn't divisible, or if the number is indivisible. And if it is divisible though, even though I already ran through that loop, because I'm going through the loop to check if it's divisible or not, I'm going to another loop to basically build up that sound. And so it's kind of good, but the fact that having two loops for checking that wasn't really like the best way to do it. Then I did that one, which is um, basically you initialize a sound, then with an empty string you going through the table, and then you're checking if the number is divisible, and you build up that sound um, that sound result, let's say. And then if the sound, if empty, um, you return the number as a string. Otherwise you return the sound. So meaning, why I did that was because um, if the sound will stay empty if there is no factor. I mean, if the number is not divisible by none of those factors here. So it will stay empty. And I will just return the number as a string. If there is some, if the number is divisible by, divisible, oh my god, I'm lost. If the number is divisible by some or maybe all of those factors here, the sound will be built up, the variable here will be built up, and I return that sound. So that's pretty good. That's even better than the other one here, because you're going actually through, you're doing actually one loop. I mean, I'm doing actually one loop. So, but I didn't really like the fact that I was initializing the sound here, the sound variable here. Then, uh, sorry. Then what I did this one, and pretty much. Oh yeah. Okay, I did this one. I returned the number. Okay, that's pretty much the code I did here. I don't know why I did that here, but whatever. I did the sun. I returned the sun as a number as a string if the number was undividable, and if it was dividable. In the case that it was dividable, you're going through the loop here, but you're using the each with object, and the each with object it's basically initializing like a memo variable, like sort of I don't know, like something you will build up over time, like to avoid this. It will do for you what is called the accumulator pattern. So meaning that you will go through a loop and then you either increase a variable plus one or you append some string to a variable, which is basically what I'm doing here because I'm happening I'm sorry, I happened this different node here from the table to the sun, and then uh, it will return the result of the memo variable, which is on here. The pair here, I did not really like it because it's not really, when you look at the code, it's not really, like you don't really understand. I mean, you will have to find out what is the pair here and why is it called pair. So, and after that, you will assume that it's an arrow or something because you see the, um, how to call that? I mean, those thing here, I don't even know how to call it in English. I forgot. And those brackets, those square bracket here, and another one here. And you can, if you go upstairs, I mean, if you go up, you can see that there is a table here. So there is a hash here, and you will see the first one is the key, and the other one is a value. But I did not really like it. So I did that. I mean, it was pretty okay because I was using this each with object method, but because you by using that you don't need to do this line here, so that's quite okay. That's actually good, but still I'm still doing this loop here to check if the number is divisible or not. So I was not really satisfied. I was actually more satisfied with that, with this one, the convert to method. And then I think, yeah, I talked to my mentor, and I think I actually told him that I didn't really like. If I find if I find the yeah, here in the conversation you can see that I send it the link to the exercise, and I said I like the one and the two, so this one and this one, because it's quite short, right? I mean, especially the one, it's really short, and the one is making two loops if the number is divisible. The two is making one loop with initialization of sound, so which is basically what I said. The three is making initialization using the each with object method, but still has two loops. I don't really like the way per index is in here, though. About to leave work. Yeah, I was at work when I was doing it, and he sent me this note. I mean, he did that for me, and I want to thank him because he's really, really a great mentor. And yeah, so he basically he wrote some note for me, and I'm gonna go through them. So he's saying that the hash is named in a way that is misleading. The idea is that this hash will store the rules, which is quite obvious. I mean, not really obvious. Even in the exercise, they're talking about rules. They're not talking about a hash factor or hash. Oh, they do not talk about like a factor tables, and doesn't really store um, what is described by the name currently. The name is not correct as it is in a table of factors, but it does represent the rules. Then on the convert one method, he said on that line, assignment within the logic blocks works, but unconditional things in conditional blocks are not really placed well. So yeah, he's saying because it wasn't really unconditional things, because in both cases I'm initializing the sound variable, even though it's initialized with different values, but I'm still initializing the sound variable. So that's why he's saying unconditional things in conditional blocks are not really placed well. What he's saying is that instead of unconditionally assigning sound in the conditional block, assign sound to the result of the logic statement, which basically I don't know what it will return in something I have to find out, because I think it's basically saying I should have done, well, even though I should have done that, yeah, that will return a yes or a no, a yes or sorry, a true or false, and according to that, yeah, we'll have to change the code here. The problem with this convert method is that it iterates the rules twice, and it's true because there is this method here which is doing a loop, and after that is going through a loop again. And the first time to see if we need to iterate for this, to iterate it for the second time, if we need to iterate it for the second time to get what we need, a better strategy would be to let the rule be iterated and build the result that we need. If we end up with an empty string, then present the number instead. No need to iterate up to times this way. Okay, then we come to the convert to method, which was pretty much like this. And in this version, we build up the string called sound. It's better formed compared to the first convert method, but only marginally. So it's saying instead of using pre-initialization of sound above, so on this line here, we can use an enumerable method that can build that string, and it can be assigned more directly in each with object, which what I did. Admin at the end, I did it here on the convert 3. And the number modulo, I don't know if it's called like that in English, modulo key, seems to be doing the work of indivisible method, but instead of doing it in an iterative way, it is checking individually which is better. Notable iteration of the rules this way. And on 3, you like it, you love it. Convert 3 now requires an iteration of the rules before uh, interacting the rules. So still using this method here. And yeah, it was because I was using the each with object, so he said, yeah, this is the solution I was talking about. And after that, he said to me, deconstruct the pair that is given with factor and node, which is quite a very, very good suggestion because I didn't like the way the pair was in there, so it didn't really make sense. And use point 3 from convert method. Okay. So then, what is saying, divisible or indivisible? Name are important, and the way this is implemented is right on, but it is in a negative aspect of an idea. I think what if we wanted to find out if a specific number was a factor of another? It would do that, right? The reason for simplifying this is we aren't interested at that point if the number is a factor of applies no sorry if the number is a factor of that applies to the rules, we can iterate the rules and ask if the number we have as the number from we can iterate the rules and ask if the number we have as the number from those will as a factor. Okay, then do the right thing. The name is seemingly missing an aspect as well. Self is a raindrop instance, and it is or it isn't divisible, but that doesn't quite make sense. Perhaps we could do something like 3 factor of 15 and get a true here. That makes better sense. Explore this though. So as you can see, it gave me quite a lot of advice, and I was really happy with that. So thank you, Victor. Thank you a lot. And so then after reading that, I was again at work on Friday. You know, Friday you don't really have a lot of things to do. The weekend is approaching and everything. And yeah, I did some modification here. So I'm gonna pull the code. If my internet wants to work. It looks like it doesn't want to work. I don't know why. My internet is dead. Oh, no, my internet is not dead. Alright, so here's a new code. And you can see there is a convert like 4. Because there is 3, the 3 previous one. And let's see, so the last one that I did was that. And so what I did here, I'm going through the table. I modified, I deconstruct the pair that was there before, and I call it factor node, like my mentor suggested. And I happened the node to the sound, and then if the number was a factor of, so this is a method I was talking about, and I put the result here. The reason why I did that here was because I couldn't really, like, I wanted to do something like this, but it's not really possible. Like, and it wasn't even, yeah, I wanted to do something like this. I'm not sure. Did I try? Yeah, it wasn't really possible because the sound here is not really, doesn't know what sound is, even though it's here, but it's local to this loop right here. So I think that is not actually working. Let's try, but I don't think it's working. Yeah, it's not working. So I did that instead. So I get the result in sound here, and then I check if the sound is empty or not, and according to it, if it's empty, I return the number as a string. If it's not, I return the sound. So in this one, it's pretty much I'm pretty cool with it. And the factor method here. So I just add a method to the fixed name, which is returning whether a number is a factor of another number, and that's it. And it's pretty. I'm pretty happy. I'm really happy actually. I don't really need that method here anymore. And I wanted to try something, but I don't remember. Mm. Yeah, I wanted me to use this requires blah blah. Was talking about the unconditional things. If yeah, it was talking about that. So basically, instead of unconditionally assign sound in the conditional blocks, assign sound to the result of the logic statement. So, and this was in a one, okay. So basically, wanted me to do something like this, I think. But it's not really, it's not even sound, it's like, dividable. And then so if dividable, yeah, if I think this is what it wanted me. I'm just trying stuff like if dividable, you do that. Blah blah blah. Okay, but there is no sound here. Yeah, if dividable, you do that. Actually, but you know, I don't really like the way it's going here. And else you do it's kind of a bit better because there is no like unconditional things like he's saying, but yeah, the way it's what that, yeah, it's actually Oh, this. Oh, what's going on? How to do that? Okay, I just want to have that in here, and I think it's that and that, right? Yeah, it should be that. All right. Blah blah blah. Return sound. I think just need that. Mm. Yeah, as blah blah blah. Actually, return. No, it's not. Yeah, I could do the return here, but I'm still going to do that anyway. So it's not even sound. If I do that, it's not. Could do that actually. Let's try this just to try. It's not working. Uh-huh. So let's see. We can do, actually, we can do that. Oh my god. It's been such a long time I didn't vote into my Mac. That's why I'm working like that. Number. Can do that. And I don't really need that. Can do something like that. Yeah, I could do, yeah, something like that maybe. Okay. So what is happening here? Should I do a return actually? Because it's doing that, but it doesn't. Yeah, I get it. Oh no, actually I didn't get it. What am I doing here? Why is this will not change that much, I think. So this one was working. Should I do that? I'm a bit stuck right here. What's happening? Okay. What is happening here? Yeah, this it should be the same, right? So what's going on with that? Okay. H Well, I don't really understand what's going on with that. I don't really understand. Because I did something like if I do that, should be the same, right? So if I do return here, I mean, I don't even need to do that. But it wanted me to, well, anyway, it was a suggestion, but I think that was the first one I did. Yeah, but I think I did that already. I did this one already. It was a bit, yeah, it was a, yeah, pretty much the same thing. Pretty much. Well, that was just a try, but it didn't really work out like I wanted, but it's pretty, I'm getting back to where I was before, and yeah, that option wasn't really like the best one. Yeah, so I'm just gonna reset everything. So that git reset hard right, and yeah, I'm gonna get rid of this. I get rid of this because I don't need it anymore, and I'm going to get rid of this because I don't need it anymore either. And I'm gonna call this rules because it's not a factor table, but it's actually a rules table. Well, I don't even need to call it table actually. And I think it did another version updated. So what did it do is probably, when did he send it? Oh, so that was convert tree, convert, okay, rules, alright. Okay, that I went through already. Okay with that. Okay with that. I mean, nothing did not really change. The only thing though, it's the zero method here. I think it's quite the same thing that I did, but because there is a method, do I really need to like do the equal 0, 0, which is, you understand, I mean, there is no difference between this and that. There is pretty much no difference, but I don't know which one it's more. Let's see. Like will be the like 0. Can I do that actually like that? Nope. Okay. So it's probably in the fixed num, I guess, class. Nope. Fix. Nope. Numeric. Maybe. Num fix. Fix num. Zero. Return true if num has 0 value. Well, I don't really know what's. I mean, it's pretty much the same thing. I'm gonna just keep it that way so far. Is that something I wanted to change again? I think I'm good. Yeah, I'm good. Not commit. Hit status. Right, you know what I'm gonna do? Yeah, and I think I'll be good for this video too. No, this is actually a commit. Yeah, next time I'm trying to like put a different tag on the commit so that I don't have to define different version of a method. I don't know how it works. I mean, I didn't really did that using tag in commit, so I think I've seen it probably in some coding company, but didn't really did it myself. So that's why. Okay. Thank you guys for watching, and see you on the next video. Bye bye.